sounding rocket is an instrument-carrying rocket designed to take measurements and perform scientific experiments during its suborbital flight. Sounding rockets are used in altitudes that are too high for an airplane, yet too low for a satellite. These rockets are used to carry instrumentation to those target altitudes, which are between 50 and 1,500 kilometers above the surface of the Earth. Nmasa has been competing in a sounding rocket competition for the past 2 years. At the competition, students build, test, fly, and compete their own versions of sounding rockets. Target altitudes for this competition range from 3 kilometers to 7.5 kilometers. A basic sounding rocket design has 4 main components. The first component is the avionics. The main objective of an avionics system in a sounding rocket is to record altitude and signal recovery events such as vehicle separation and parachute deployment. Typically, the system has components like barometric pressure sensors and accelerometers, but more advanced systems will also include GPS receivers and telemetry transmitters. Another important component of the sounding rocket is the propulsion system. There are 3 different types of rocket propulsion systems: solid, liquid, and hybrid. These propellants range from simple sugar rocket candy to liquid hydrogen and liquid oxygen. The propulsion systems are typically used in stages where the components are designed to be jettisoned after use. The motor shown here is an example of a solid rocket motor. Things that go up must come down. So to help ease this process of coming down, we use parachutes. Not all sounding rockets require recovery, but when they do, they typically have single or multiple parachutes depending on the size and purpose of the rocket. These are deployed using ejection mechanisms built into the rocket. Another integral part of a sounding rocket is the structure. Lightweight materials such as carbon fiber and fiberglass are commonly used to make up the structure of sounding rockets. Other materials such as aluminum are used to make joints and collars for the rocket. The final structural design must resist buckling, be lightweight, and ensure aerodynamic stability. Put all these things together and you have a sounding rocket that is ready to compete. The design team has been thinking of alternate applications for sounding rockets. One concept is a high-speed homework delivery system to get assignments in on time. However, it is still in the works.